Yeah, looks like it's recording.
Okay, so a new topic today. New topic today, production possibilities frontier. Yeah, looks like perhaps the computer can hear me. So, who can tell me what is a frontier? Frontier. I think it's something like the edge or the border, right? So, from the name production possibilities, frontier is at the edge of what we can produce. Okay? So it's a combination of goods and is a border between. Okay, so production possibilities frontier, is a border between the combination of goods and services that can and cannot be, I think I have a typo here. Okay, let me repeat that. It's a frontier between the combination of goods and services that can and those that cannot be produced. Okay? Probably doesn't make much sense. If it doesn't, don't worry. I'm going to give you an example. Everything is going to be really, really clear. So let's say, for example, you have your own bakery business. And let's say you make, I don't know, what do you make in that bakery? Let's say you make buns and cakes. Okay, let's say you make buns and cakes. And the more time you spend making buns, the less time you have to make cakes, right? And vice versa. So let's have this example where you have, let's say, 6 options during the day. Option A, B, C, D, E, F. 6 options where we have buns and cakes produced during that day. If you spend no time producing buns, then let's say during the day you will have enough time to produce 15 cakes. Okay? If you spend time to produce 1 bun during the day, then perhaps the rest of the day is enough to produce, let's say, 14 cakes. If you spend time to produce, let's say, 2 buns, then there is only time left during the day to produce, let's say, 12 cakes. If you spend time to produce 3 buns or 4 buns or 5 buns, the remaining time is only enough to produce, let's say, 9, 5, or no cakes. Okay? So, what are these? These are the combinations of goods and services that you can produce, right? For any given day, on Monday or on Tuesday or on 24th of October, on any given day, you can choose how many buns and cakes to produce. The maximum amount of buns to produce, perhaps they are more time consuming, per day is only 5. So you can choose anywhere between 0 and 5 of the quantities of buns to produce. And whichever you choose for the buns, the remaining time is only enough to produce a given number of cakes. Basically, that's a combination of things and a combination of these 2 goods that you can produce. Instead of goods, we could also have services there, right? Now, what is a production possibilities frontier as a chart? in economics, as I mentioned last week, we are going to use a lot of charts, a lot of graphs. We just put those numbers on this chart, that is all. Very, very easy. Let's say 1, 2, maybe that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And so the horizontal axis goes all the way up to 15, yes? So you should be careful here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So that would be 3, 4, 5, 6, 7, 8, 9, 10, and 15. Something like that. Right? So option A is over here. Yeah. This is option A, to produce no buns, meaning that you spend all the time producing cakes. Option B is over here. Right? Option C is, that's what, 12, right? 12 is right here, so it's somewhere here. That's option C. Is it a bit higher? Option D, 3, and how many are there? 9, yes. 3 and 9 is somewhere here. A, B, C, D. Option E, 4 and 5. Yes, 4 and 5, thanks, yes. And option F is to produce only bonds, right? So once you connect all of those points, let's say I got the D as well. Once you connect all of those points, what do you get? Is a chart. What do you get? Is a graph of PPF. So that is a production possibilities frontier. I'm going to use PPF for that. If you're using different textbooks for economics, or if you're Googling things online, there's another name for PPF, which is PPC, production possibilities curve, because that's like a curve, right? So PPF, production possibilities frontier, PPC is the same. And based on the definition, look, it's a border between the combinations that you can produce and those that you cannot produce. So for example, any point on the PPF, like A, B, C, D, E, F, those are all the combinations of buns and cakes that you can produce, right? We've started with the assumption that you can do these, right? Any point inside the PPF, like over here, A, B, C, D, E, F, G, that's point G, where you produce 2 buns and only 6 cakes, is also possible. You are just being lazy a little bit, because when you produce 2 buns, you have enough time left for 12 cakes. But instead, if you just produce 6, perhaps you are taking longer breaks, right? So it's also possible, G. So all of these points, all of those points on the PPF as well as inside the PPF, they're all called attainable. Maybe I should write inside, so it's very clear. Attainable means reachable, possible to get to, right? You can get there, okay? And how about this point over here? Let's say that's, well, let me raise it a little bit, because it's somewhere between 4.5 buns. Perhaps you don't want to bake 4.5 buns, nobody's going to buy that half. So let's say 5 buns and 17 cakes. If you bake 5 buns at your skills level right now, baking 5 buns takes whole day, right? There's no chance you can, in addition, create another 17 cakes. Okay? So that point, A, B, C, E, F, G, H. That point H is impossible for you to get to, right? At least with the current skills. So all of these, all of that area above the PPF, okay, is called unattainable. Unattainable. Why did I do that? So, yeah, it's a border between the things that you can produce and you cannot produce. Now it makes sense, right? At the beginning, just one sentence. What is he talking about? right? So we like to use all these charts and numbers in economics. It makes things easier to understand. Yeah, it means that maybe you need to do a little bit of math, but nothing really difficult. I know some people are kind of afraid of mathematics, right? Things are pretty easy. Okay. So that's good. And as I mentioned to you during the Smart Tech class, right? You don't want to learn only descriptive things like the sentences, right? Like, okay, triangle is, I don't know, a shape that has 3 sides. That's a description, right? Those things kind of make you memorize the information, right? You aren't going to be successful over the next 10, 20, 30, 40, 50, 60 years if you just learn to memorize stuff, right? You're going to learn to understand things and then transform things into new ideas, right? That's how you will be successful. I told you about that during the Smart Tech class, right? So that's why, as I mentioned, I don't really like it when I have to test you on just memorizing some descriptions, right? Perhaps we've got to do something like that for the Smart Tech class because the calculations there are impossible to do by hand. All the calculations are going to be done by computers, right? So nothing for me to give you to calculate. But for economics, it's a very interesting class. I really enjoy teaching it because we're going to have a look at things like this, where you really can apply this understanding and kind of do some analysis, right? Like, for example, what happens to the PPF if you employ someone to work in your bakery as well? Is it going to shrink or expand? How do you guys think?
Expand.
Expand, because you will be able to produce more. You have 2 people in the bakery now, right? So, I mean, this really is understanding the topic and being able to adapt to changes, right? Yes? So, if you search online or in newspapers, nobody's reading newspapers right now, there are economics-related news all the time, right? We're talking about economics right now, right? Unemployment, interest rates changing, the Federal Reserve tapering the monetary policy, right? What is all of that? What does it imply for me as a business owner, for example, right? If you're a business owner, well, perhaps if interest rates are changing, well, maybe it's going to be more difficult to expand. If interest rates are rising, it will be more costly for you to borrow that money to build a second factory, right? So all this is extremely interesting. I really think it is very interesting. And in future, if you want to be successful, right? If you want to run something of your own, it's really beneficial if you understand something from economics, right? So, yeah, I hope you guys will enjoy this class. And we'll have a lot of charts and tables and graphs for you to enjoy, okay? So, how about this point G? What can you say about the efficiency of producing this combination? Because any point is a combination, right? Any point here is a combination because we have 2 goods on the horizontal and vertical axis. So how about producing at point G? What can you say about the efficiency of producing 2 buns and 6 cakes? Is it efficient for your business? Not really, because you are taking breaks that are too long, right? You could be making more money, sell more cakes, right? Or more buns. So this G can be moved higher to this point, what was that point? I don't remember. Or this G could move to the right to point C, right? So either you could make more buns or more cakes, right? Who knows? But anyway, it's not efficient. So any point on the PPF is efficient. Okay? Any point under PPF is inefficient.
So all attainable points are inefficient?
No, the points on the PPF are also attainable because at point D, for example, I can produce at point D, right? I can make 3 bonds and at the same time make 9 cakes. So both points D and G, those are both attainable.
So all points,
On the
all the
PPF,
attainable points inside the
PPF are inefficient, absolutely right, yes.
Okay.
So any point under PPF is inefficient. Of course, over PPF would be even better, but we can't go there. It's impossible, right? Okay. Well, actually, let's add one clarification here. We're adding one clarification because later on we will find out that, well, there are different kinds of efficiency. Okay, there are different kinds of efficiency. So which kind of efficiency are we talking about? Well, we're talking about productive efficiency. Okay, so any point on the PPF is productively efficient. But there is another type of efficiency, right? Let's say, for example, it's not buns and cakes, but let's say, for example, it's stinky tofu and cakes. Right? I much prefer cake to a stinky tofu. I don't know how about your clients, right? If you are baking it for your own family, then it depends on your preferences, right? If you are making these both as a business, it doesn't depend on what you want. It depends on what the customers want, right? Anyway, if I'm making it for my own, right? I've only tried stinky tofu once, I think, in Taiwan. In I've been here for 11 years. I don't really love it. So I much prefer cake. Right, so point A, B, C, D, E, F, this is F, right? Point E is productively efficient, right? I don't waste any time, right? I don't take breaks that are too long. I do produce 4 portions of stinky tofu, right? And however many cakes, right? Yes, which the time permits me. But if it's for my own, if it's not for the business, right? Why do I make so many stinky tofu portions if I don't like it? It doesn't make sense. Yes, I'm working hard. I'm not wasting time, right? But it doesn't make sense. So there's another type of efficiency, okay, called, maybe let me write it there because I think the computer is looking at this direction more. Which is called allocative efficiency. Allocative. So, I know the computer doesn't see things very well on the board, so just listen to what I'm saying, those who are watching this online, right? So one type of efficiency we've mentioned several minutes ago was productive efficiency. I'm trying to be productive, I don't spend time, I'm working hard, right? I'm productive. But I'm allocating my time doing what? Yeah, I'm working hard, but am I making the things that are necessary? Or am I making things that are unnecessary, like stinky tofu for my family, nobody likes it, right? What am I going to do with all of that? So allocating time properly, right? So I'm just trying to give you some examples to connect with the name so you remember. So allocative efficiency. It's not only about allocating time, right? It's allocating all the different kinds of resources in economics that are, we've talked about different four factors of production, which include thousands of different actual types of resources, right? Electricity, water, human labor, human knowledge, right? This oven and the office space and the kitchen space, everything, right? So allocating all of those resources, right? I'm just talking about time because it's easy to give a simple example, easy to understand it, right? But it's in general in economics about allocating your resources properly, right? Let's say you're somewhere in, I don't know, California in a particularly health-conscious environment, right? Where people are jogging every morning, maybe sometimes even at night as well, right? Perhaps they go to the gym sometimes. They have a standing desk. They don't sit in front of the computer like I do. Wow, they have a standing desk. Some of them even have a treadmill in front of their desk, right? And you open a McDonald's there. You work hard, right? All your employees are working hard. You are whipping them. Don't let them take too long breaks, right? But that's not allocating the resources efficiently, right? Who's going to buy your burgers? Those people are probably going to buy the salads from Subway or something, right? So there's that. We're going to talk about allocative efficiency a bit later in more detail, because there's also in economics, it's really, really interesting. Again, we don't just talk about these kind of ideas, right? We can illustrate them somehow with charts and numbers. How amazing is that, right? Spending time making stinky tofu. Doesn't make sense, right? So it's easy to understand, but it's just one sentence. But in economics, we can somehow put it on the chart. How cool is that? I really love it. So, oh yeah, next what I need to talk about is opportunity cost. Yes, opportunity cost. We've talked about opportunity costs last week, right? Can you guys remind me what is an opportunity cost? It's something that I have to give up in order to do anything, right? Remember last week we had an example. I went hiking, right? And the hiking takes 3 hours, right? And to take the bus ride to the place where I'm going to go hiking is going to cost me 60 NT. Plus, during the 3 hours, I could have done something else, right? So the actual accounting cost, as those accountants look at it, is only 60 NT, the cost of going hiking. But economic cost, including opportunity cost, right, is 60 NT plus whatever else I could have done. So over here, we see opportunity cost somewhere, right? Let me redraw it because it's a bit too messy. Okay, I'm going to leave that. One, two, three, four, five. Okay, that makes it bonds here. That doesn't really matter. It doesn't matter. One, two, three, four, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? So one is here. Yes. Then 1 and 14. Then 2 and 12. Where's 12? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12 is here. Right? Then what? There's 9, yes. 9 is here. Then 5. 0. Okay, here's the PPF, right? Okay, so let's start at this point. What was that point? That's point A, yes? Let's start at this point A. As I move from A to B, I get something, right? I decide to make bonds, right? Because at point A, I decide to make 0 bonds, but at point B, I decide to make 1 bond, right? So any activity, we said in economics, has opportunity costs. Maybe also actual monetary costs, but at least opportunity costs, because you could have done something else instead of that. So I get 1 bond, right? But I have to lose something, right? Did I pay something for my own bonds? I made them myself. Did I pay with money? I didn't pay with money to anyone, right? Because I made my own bonds, right? Yes? But there is still opportunity cost, because during that time I could have made cakes, right? I could have made cakes, right? So as I move from A to B, right? As I move from A to B, I gained 1 bond, but I lost 1 cake, right? So in this case, as I move from A to B, the opportunity cost of 1 bond is 1 cake. So I'm going to put here opportunity cost equals 1, right? Opportunity cost of this one additional bond is equal to 1 cake. But as I move from point B to point C, I gain 1 more bond, right? So next day I decide, oh, let me try to make more bonds. So I gain 1 more bond compared to the previous day, not compared to 2 days ago, right? So I get 1 more bond, but I lose more cakes in this case. I'm going to go down from 14 to 12, I'm going to lose 2 cakes, right? So in this case, even though I don't pay for my own bonds, right, I lose the opportunity to make 2 cakes. So the opportunity cost here is equal to 2, right? And so on, it actually changes, right? It's actually changing. So over here, for the third bond, the opportunity of the third bond is 3 cakes, right? Opportunity cost of the fourth bond is 4 cakes, and the opportunity cost of the fifth bond is 5 cakes. The opportunity cost of the fifth bond, not 5 bonds, right? How do we look at the opportunity cost of the fifth bond? Well, compared to one less, when I have 4 bonds, I still have 5 cakes as well. Yeah, when I have 4 bonds, I still have 5 cakes as well, right? But instead, if I have the fifth bond, I have no cakes, so I lost another 5 cakes, right? So opportunity cost of the fifth bond is 5 cakes. If we go the opposite way, right? If we go the opposite way, you will notice that opportunity cost is just the inverse. In economics, inverse is a number which you put upside down. For example, A over B is the inverse of B over A. Okay? So, let's have a look at an example. As I move back from point F to point E, as I move back from point F to point E, at point F I have no cakes, right? At point E I have 5 cakes, right? And how many bonds do I lose? I lose 1/5 per cake. Let's do it again. At point F I have no cakes, right? At point E I have 5 cakes, right? For those 5 cakes I lost 1 bond, right? So how much is the cost of 1 bond? How much is the cost of 1 cake? 1/5 of a bond, right? So imagine you buy 5 bananas for $1, right? How much is the price of banana? 1/5 of a dollar, right? Is that right?
Yes.
So a cost of 1 cake as I move from F to E is 1/5 of a bond, right? Did you get it? As I move from F to E, I used to have 5 bonds, then I lose 1. So the cost of all 5 cakes is 1 bond, right? I got 5 cakes for the price of 1 bond. It's just like I got 5 bananas for the price of $1, right? Then how much is the price of a banana? How much is the price of 1 cake? One of those 5 is 1/5 of a bond, right?
So if you have 4, if you make, so the next one will be 1/4.
Exactly, yes. So that's inverse, right? Because 5 is the same as 5 over 1, right? And the inverse of that is 1 over 5, right? There's the inverse. So the inverse of 5 is 1/5. The inverse of 4 is 1/4, and so on. The inverse of 1 is 1. Right? So that's the opportunity cost of bond's opportunity cost, bond's opportunity cost, bond's opportunity cost, bond's opportunity cost. Then the cake's opportunity cost, opportunity cost of cake is still 1. Opportunity cost of cake is 1/2, right? Opportunity cost of cake is 1/3 over here, and so on. Opportunity cost of cake is 1/4, and opportunity cost of cake is 1/5. Okay, let me give you another example of a PPF. We'll come back to that example. It's quite important about the shape of the PPF. No, let me change it so the numbers are even easier. It's going to be even easier. So let's say we are, I don't know, origami. Let's say we are folding paper, right? We are folding paper, nothing really difficult there. So one is complex origami, one is easy, right? And let's say one origami takes 5 minutes, another takes 10 minutes, right? And it doesn't matter how many you do. They're always taking 5 minutes and 10 minutes, okay? So in that case, the PPF will look like that, right? So the exchange rate of one origami for another will always be 1 for 2, or 2 for 1, or 1/2 for the other one, right? Because it's in reverse depending on which one, the cost of what you're looking at, right? Right? So in that case, PPF is straight. How come it's not straight here? Right? So when we're looking at some extremely simple examples, right? When regardless of how much of the activity you do, the opportunity costs stay the same, PPF actually is straight line, right? So let's say, for example, this is origami A, difficult one, and this is origami B. Okay, no, let's call them easy and difficult. Easy and difficult, right? So we have two kinds of origamis here, easy and difficult, and let's say difficult origami takes 10 minutes, and easy origami takes 5 minutes, and let's say you have 20 minutes break, right? How many origamis can you make? A combination of them, either one difficult and 2 easy ones, or 2 difficult ones, or 4 easy ones, right? If you make 3 easy ones, you will not have time to complete a difficult one, right? So let's say this is a 20-minute PPF. Of course, if we have a day to do it, then we add zeros here, right? Because you have a whole day to do it, right? If it's a 20-minute, then 20-minute PPF will look like that, without the zeros, right? This is one you can do in 20 minutes, right? Okay. So whenever opportunity cost is the same, doesn't matter when you make 0 small origamis, or 2 small origamis, or 4 small origamis, doesn't matter. If they're always, opportunity cost is the same. Small origami always costs half of the big one, because it takes 5 minutes to make. In that 5 minutes, you could have completed half of the big one, right? Then PPF is flat. Over here, PPF is not flat. Why? Because the resources can be more or less productive at a given activity. Okay? So let me now try to explain that, okay? So let's start from the start, and let's say we have not a bakery, because it's kind of difficult to understand with a bakery. Let's say something very different, 2 very different activities. Let's say presentations and essays. Okay? So let's say you have a group project, right? And for the group project, you need to write I don't know, 5 essays and make up to 15 presentations during the semester. Okay? But it's a group project. You can split the tasks, right? And some of you within the group, there are several people in the group, right? Some of you are really bad at presentations. You are very nervous. In order to encourage yourself to actually go and present in front of 50 people, you have to go over your presentation slides 32 times, which takes 7 days, right? So if you are thrown at a presentation task, you'll be really slow, but you are a really good writer. You can write pretty well, pretty good essays pretty fast. Some are opposite. They're no good at writing, but they're okay talking, right? Like I'm just talking now. So they can make presentations, but they can't really create anything. Okay, they can have a chat. So different people in the group, right? And if you throw everyone to make presentations, right? You will be maybe over here, right? Whatever it is, let's call it 15, whatever, just so the numbers are the same. But it doesn't matter, right? Now, if you decide to have some essays as well, right? Yes? Are you going to send a good talker to do the essay? Probably not. He'd better do the presentation, right? So if you send a good talker to do the essay, right? If you send a good talker to do the essay, what's going to happen is you're going to lose a lot of presentations, because the rest of the people who aren't good at making presentations, they will have to spend ages to prepare for those presentations, right? So instead of 15, you will only be able to make 6, right? And just for one extra essay, that guy is really great at making quick presentations. If you send him to do the essays, everybody else is no good in making presentations. The next point is going to be over here. It doesn't make sense to send somebody who's good at presentations to send him making essays when you still need to make presentations, right? So you're going to send instead somebody who is no good in presentations and who is relatively good at essays. You're going to send him to do the essays, right? So, because he's no good at presentations, you're not going to lose much presentations, right? But he's pretty good at making essays, so you're going to get that essay, right? Then, if the assignments during the semester change, in addition to one essay, you will still have to write another one. You're going to send somebody else to do the essay, right? Same idea applies, right? Among the remaining people who are within the team, right? Somebody will have to do the essay. You're not going to send somebody who is really good at presentations. You're going to send somebody who's pretty good at essays. This guy was really good at essays. That's why the cost of presentations was very small, right? He's going to write that essay really fast. So within that time, you couldn't have prepared much presentations anyway. That's why the cost is so small. But he's already working on that essay. So next guy is not as good. Because if the next guy was better than this guy, you would have sent him instead, right? So the second guy is not as good as the first guy in making essays, but he's still pretty good. Because it doesn't make sense to send somebody who is really good at presentations and really bad at essays to send you the essay, right? Okay, so he's pretty good, but not so great. So it's going to take him time to write the essay. In that time, you could have made some number of presentations. So you see this arrow becomes a bit bigger, right? And you're going to get that second essay. And so on and so forth until you have to make too many essays. Then every last person, even who is no good at essays and who is really good at presentations, will have to do the essay, right? And then if that last person who is really good at who is really good at presentations but really bad at essays will have to do the essay, then if he's really good at presentations, you're going to lose a lot of presentations. And we'll get that one last bit of essays, right? So, production opportunity frontiers, PPFs, they look straight when the opportunity cost of the goods are always the same. That's when the resources are always equally good at two tasks. When the tasks are really simple, just folding paper, you could have folded it this way or that way. It's always going to take either 5 minutes or 10 minutes. But when there is a diversity in the resources, right? It's not only one person working, different people working. Some people are good at one thing, and other people are good at other things. When there is diversity in resources, right? The PPF will look like an arrow, not an arrow, what is it? A bow. It looks a bit like a bow, right? Okay? Questions? Let's go for a break.